My little project today is going to be a simple little constant current load. So I've wanted one of these for a little bit to test power supplies and other things just to make sure they can output the power they're rated for, and you can change the current without changing the voltage and some other fun things. This is the circuit on the breadboard. My breadboarding just sucks, but you can see kind of what it is. The basics is you have an op-amp, which its goal is to keep the two inputs the same, and you have the two inputs, the voltage of the shunt resistor and the voltage of a potentiometer, which will be adjusted to change. And it tries to keep them the same, and it does that by changing the voltage going into the gate on the MOSFET. Now, this is my breadboard mock-up. My breadboarding sucks. I'm going to eventually be building it on this little perf board here, and I got a few other parts. So, I got a few other little parts to make this more fun. So, I'm going to be using, because this is essentially a heater, a glorified heater, I'm going to be using this little cooling fan I got to basically bolt on here to cool the MOSFET, because that MOSFET makes a lot of heat. You can kind of see it in here. I have this big power resistor. It's a 5 watt 1 ohm resistor, so it's good for up to 5 amps. Normally these are cooling limited, so they get stupid hot, so you just want to be careful about that. Here's a little fan. It's going to be bolted on. And then I have two more pots that I'm going to be using for a fine and coarse adjustment because I couldn't find a 10 turn. I want to use a 10 turn so I actually have reasonable precision adjustments, because the problem with 1 turns, if it's 0 to 5 amps approximately, that doesn't give me much adjustment if I want to do 200 milliamps, for example. Now for testing, this is going to require 2 power supplies. I was trying to do it with 1, it just didn't want to do it very well. So if I fire up 2, I have 1 power supply that's going to run the power of the op amp. Basically that's about it. The other guy, which is the actual load testing. Now unfortunately this does make it a bit harder for you to see what I'm doing because I can't show you everything, but I'll try to talk you through it. So I can now turn this dial and change the amount of current it's pulling. And if I change the amp, and if I change the voltage doesn't change the current at all. Now though, what I do have is I have a few multimeters around, which I'll read you the values of. This guy here is reporting the voltage that's going into the gate of the transistor. This guy here is reporting the non-inverting input, which is from the potentiometer, which determines current. And this meter here, which you can't see at all, is reporting what the shunt resistor current is. So if I adjust it, you notice if this guy's working correctly, the voltage of the shunt resistor, which currently is 0.3, and the voltage of the potentiometer, which is also 0.3 right now, is virtually identical. And what that will do is they will change this to basically be the same. Now I'm using currently an LM324. I used it because I had it laying around. It's quad op amp. I've seen people using it. I was playing with other parts because it was doing something really weird a little bit ago and only would go from 1 amp to 1.5 amps and wouldn't go to 0. And I want this to go to 0. I have no idea why. I'm basically only using 2 op amps on the quad right now, and basically one of them's acting as a buffer, and the other guy is acting as the actual control op amp. I've seen a ton of circuits online that cover them on resistors and capacitors. I'm not using the capacitors, not really an issue with that. I've tried using the resistors. I moved it around so it didn't use them, and it worked fine. I've seen resistors between the output of the op amp and the gate. Could be something to keep the current from going too high. I haven't actually measured the full current on that, but it was seeming to cause issues, or it was something else that's not a good connection. Connections on these perf boards are going to be a lot better than my breadboards, because these are horrible. I need to get reasonable wire and stuff. While it's probably not the best solution, I might just use an LM324. I have a couple of them laying around, and they don't get used too much. This is my crude schematic of the constant current dummy load circuit I made. So these are the 2 potentiometers. This is the coarse one, this is the fine one. The fine one basically adjusts whatever adjustment the coarse one made. It's not the best arrangement, but it works. LM324 here, this guy's acting as a buffer, this op amp here. So as in the inverting input's plugged into the output, and the non-inverting input's plugged into the potentiometer's output. And then this guy here is what manages the load. So here's the current shunt resistor, so the output of that goes into the inverting input. The non-inverting input's plugged into the buffer, and the output's plugged into this MOSFET here. And this connects to the load. I have a capacitor here to try to reduce ripple, as I was noticing it was kind of overcompensating and stuff in the earlier bit and causing more ripple on the load rather than almost none, which a true dummy load should do. Have another capacitor on the input just for good measure. And this is my crude one right now. I might make a better one in the future that can handle much more current. So I just finished building this whole thing, and there was a little bit of annoyance, but it actually worked pretty well. So the big thing you see here is this heatsink, and this heatsink is really mainly held on to the TO220 MOSFET here with this little screw. Holds in surprisingly low. I chuck some thermal paste in it because I want this MOSFET to stay as cool as he can. And yeah, and then the fan's wired in here, runs at full speed. Basically just don't put more than 12 amps in it. I have two pots here. One is, this guy is the coarse, this one's fine. They're basically just wired up in series. Isn't the best possible way to do it, but actually works relatively well. This is the main current shunt resistor with an electrical taped lead so it doesn't touch anything. My idea in putting it here was to try to keep some airflow going past it. I was intending for this to be a bit lower than it happened to be. I was also should hot glue or something else to attach this in, keep it from shaking as much. I have a filtering cap for the power input here. On the back, quite simple actually, mainly just a couple of these power lines here and a couple other little connections, but really not much to it. So that was my simple little thing. Let's go look at a little test and see what's an application I might use something like this in. And now that the board's done right here, I'm set up a little test set to show you what something I might do with a product like this in the future. So here's my little test bench right here that I have, and I'll explain what everything does now. So the first thing I have is, this is a little switch mode power supply, came from I think an external hard drive box right here, 12 volt, 5 volt. I don't know the full specs on it, but it's right here. And then the monitor, here's the input, 120 going in, so I have a kilowatt meter. These are actually kind of useful to have, they're relatively cheap too. I have a clamp meter measuring current as well, because I can, and I'm not too sure about this guy right now. HP multimeter measuring the voltage coming out, it's 12 volts out. This guy's measuring current coming through. And probably the more telling one is this, is the scope measuring the waveform. So I can see what the waveform is. And because this is an adjustable load power supply, I can easily crank the load up, and you can see as I turn the load up, I'm pulling about 300 milliamps right now. And then now I'm at about half an amp, and more and more and more. And you can see my voltage has dropped, because with no load, my voltage is about 11.8 volts. And then when I'm at, here's a full amp. And then when I'm at 1 amp, I'm seeing about 11.4 volts. So this isn't a very well regulated power supply. This is a pretty much bottom of the line switch mode. And you can see also the low power factor of about 0.6. Efficiency rating, you can also get that because I'm pulling about 20 some watts of power. And that's weird because the kilowatt says 15 watts. And that's probably due to the kilowatt being off with this. This guy's saying 0.2 amps, which the other kilowatt's also saying, what is it saying amps-wise? It's saying 0.22, so it's pretty close amps-wise. It's just probably due to something with power factor, and I know the kilowatts. And then once I get past about 1.6 amps, it just gets wonky. That's quite a bit of ripple. And for scale here, each one of these is 5 millivolts. So if I put on a 20 megahertz limit here, bandwidth limit, which doesn't really do much in this case, and I change the trigger level, you can see the pretty nasty waveform here. That's roughly, I don't know, how many, maybe 20, 30 millivolts peak to peak of ripple, which is okay. It's actually not that bad. And if I keep turning it up, and I get this really weird, the ripple virtually disappears at about 4.2 amps. So thanks for watching my little video on this constant current power supply, and subscribe for more videos like this in the future.